Hello.
Whoa, hey there.
What are you
Back in the cave,
doing?
I see.
I don't know what's scarier, this cave that I just crawled out of, or that equation behind you. Oh my God. Oh, I don't know
Wow,
what's
do you
lurking in the.
recognize this formula?
It looks, let me see, is that an equal sign or a minus sign behind you? Let me see. It's an equal sign. Hold on. So I've
It
got
should be an equal
natural
sign.
log.
Okay.
I see it. A P of X over 1 minus
Mm-hmm.
P of X. So something's happening or something's not happening, it sounds
Mm-hmm.
like. And then that looks like we got some kind of a linear equation
Yep.
there, right? In different values, X1, X2,
Yeah,
X.
I
Oh,
would
okay.
say so.
Okay, so we have a bunch of independent variables, X1 through Xn, if I'm not mistaken. And all right, so it
Mm-hmm.
looks like multiple linear regression. No, multiple
Kinda,
logistic
almost.
regression. Logistic regression.
Yes, precisely.
Ah, because of that other sign on the left-hand side of that equality, right? That's right. So if it was y
Mm-hmm.
equal to this, that would be multiple linear regression. But it's a natural log of
It would
P
be,
of
yes.
x, something happening, probability of something happening,
Mm-hmm.
divided by the probability of it
Mm-hmm.
not happening. Right? Is that right?
Yes.
So that's like, what's that? The odds
Mm-hmm.
ratio? Natural log of the odds ratio? Is is this
Yeah,
called?
you can use Steele's ratio.
Remind me what this is called. This particular function, the logit
So
function.
this is, yes, the logit function.
Logit function.
And
Okay. Oh, log. There's a log right up
yes,
there, right? Okay.
indeed. Now you have to clear something up for me
Oh
because
man.
when I when I was in school and when I was in university, this was always pronounced lun, but everyone who I spoke to who wasn't from the UK pronounced this as log.
What did they?
So
They would
you
say un, just with no syllable,
learn.
no vowel.
Hmm.
That's weird.
Yeah. So
Sorry.
I've
I don't mean
always
to.
known this as learn, but hearing other people say log, I would put
Natural
like
log.
LOG. Yeah.
Is
And then
that?
there'll be just a bit of
Okay.
confusion going on.
A
So
little
learn
bit.
and
A
the
little
natural
bit.
log,
Lynn
they're the same thing.
Lynn. Oh, that's okay. As long as there's translations, there's always something that means something. Means something,
Hmm.
even if we speak the same language, right? Okay. Yeah. Yeah. All right.
There we
So
go.
can we call it natural log from now on? Give it a nice
Yeah,
formula,
that's fine.
and throw in Lynn every once
Hmm.
in a while, just to keep people on their toes.
There we go.
Okay. All right. So I'm thinking, okay, so maybe we should describe what this might give us as far as like, what the probability might be of something happening given some other variable. What's a good example? Let's think. I could, I don't know, develop or not develop heart disease, depending on what my
There we go.
cholesterol level is, right? Well,
Hmm.
I don't know if that's, I think that's something. I don't know. I'm just saying that there's some kind of independent variable that may have some kind of a, I'm not say effect, but may sort of be able to predict whether something's going to happen or not, or what the probability is of something happening or not.
Yes.
Right? Okay.
Yep.
So we get these nice curves, I imagine, right? I
Hmm.
think this is what I've seen. Can I share my screen?
Yeah, of course. Go
Is
for
that
it.
all right? All right. Actually, I'm going to try a whiteboard here. Whiteboard. Okay. Is it popping up? Do you see it? Do you see it?
Yeah, it's up.
It's coming up. It's not up
Fantastic.
for me. It says loading your whiteboard.
Ah,
A little
interesting. We'll
tick,
give it a
tick, tick,
minute.
tick, tick. Maybe my internet's not as fancy here, and I won't give my
Yes.
exact location. You
Oh,
don't want all
you
the fans coming in, knocking down on my door and says, "What was that about logistic regression?"
goodness me. People are very passionate about these things.
Yes, they are. We have to be careful. It says, "Wait a minute." Okay, hold on, hold on. It's coming. Ah, here we go. Okay.
There we
So
go.
So we've got, hopefully my handwriting isn't terrible because it has been for a while.
That's fine.
It's hard to see in that cave, when I'm writing notes and stuff. It's a little bit
Of
difficult.
course. That's why the internet's a bit spotty as well.
That's not bad. My handwriting hasn't suffered that much. So P of X, uh, I
Hmm.
spoke too soon. 1 minus P of something happening. So the probability of X happening, whether X is a 1 or a 0, let's say, if it's logistic regression,
Yep.
0 meaning maybe you don't have heart disease, 1 meaning that you do develop it. Okay.
There we go.
So that's equal to, and I'm going to give it, okay, just one variable,
Sure.
not plus beta 1. We'll just say X, big guy X here.
Nice.
So maybe to be more specific, and I hope this is correct, I'm going to say probability of X equaling 1, meaning something has happened,
Right.
and X equaling 0, meaning that that has not happened. So we can define getting heart disease as X equaling 1, not getting it as X equaling 0.
Okay.
Right?
Would
Okay.
we need the 1 minus then, if that's the case?
Yeah.
Okay.
Yes. Thank you very much. So the bottom bit.
Oh, right. Yes.
That's right, man. That would have been a major mistake there. And I didn't put it on. I didn't put it in here to try to catch you out on a mistake. Seriously, because sometimes I'll do that.
Oh, no.
Probability, God, that's terrible. Probability of X equaling 0, or, oh, God, that's bad. Or this is exactly the same as the natural log of something happening, X equaling 1. And then since it's 1 or 0, makes sense that this guy would just be 1 minus P. Probability of X equaling 1. How's that?
So good.
Thank you for catching that. Thank you very much for catching that. Wow. That was a legitimate mistake. All right.
That's right.
Cool. Don't hold it against me. You or the
No.
viewers, don't hold it against me, okay? All right, here. Oh, it's because I didn't have my glasses on.
Oh, there we go.
Well, yeah, okay. Some excuse always. If you have a good excuse, you don't need, you don't need anything else, do you? No, that's not very good. That's not a very good thing to broadcast. Okay, so we have this, right? Beta, beta. So this ends up being the natural log of this ratio, this odds ratio, right? Turns out to be some kind of a linear equation. So we're trying to estimate what beta 0 and beta 1 are. Okay. Now, the thing that I think that's important here is to kind of see how we may be able to lay out X across the bottom, right? Okay. So I'll lay X across the bottom here. So here are values of X right here, along here. Okay. And here we're going to have a 0 and a 1, right? And if things like, for our example, if we find out that a lot of people with the lower cholesterol level end up having no heart disease, maybe one of them has some heart disease, you never know. But then we find out as the cholesterol gets bigger, right? These higher levels of cholesterol tend to give results of having that heart disease. There may be some that have high cholesterol that haven't developed it, but we may get something that looks like this. I know that's a terrible drawing, but we could be able to talk about what's the probability, because I've got any probability is going to be between 0 and 1, right?
Absolutely.
So we can say, all right, well, as I'm moving along this direction here, I'm going to use different colors here too, since my drawing is terrible. Maybe the colors will make people realize maybe our stuff increases as we move this way. Right? Okay, so we get up with higher and higher and higher probabilities. Sure that these are not going to shoot up to 100% or 0%. But we get some kind of behavior like this, and then we can figure out if that happens to be significant, if there truly is some kind of relationship where we might be able to predict or at least get what the probability is of somebody developing heart disease, given cholesterol level, given maybe some other independent variable, correct? Okay. Right. So maybe it's a good idea to kind of show what the heck this line, what kind of equation, because it doesn't look linear, but I got some logarithms here, right?
Mm-hmm.
So maybe, should I get rid of this? Should I get rid of this? Yeah. Or should I come back to it?
So
So
do you?
let's get another page. Can I get another page? What's this? Mini map? No, thank you. How do I make it big? Oh, I can zoom out. Or can I move it? Here, let me try to move it. That way. Opa, that didn't move it. Hold on, let me see if this works. Opa, that zooms it in and out.
Oh, there we go. So you
Okay.
can make this very
Here we
tiny.
go. Here we go. We got a little bit of space down here.
Oh, fantastic.
Isn't that nice? Okay. All right. High tech. So I'm going back to this top equation again. Let me get the pen. Going back to this top equation, I'll use, I don't know, I'll use another color. I'll use purple. No, I won't. I'll use black. Be professional. Okay, so natural log, this bit, p of x equaling 1.
Mm-hmm.
I'm just going to use shorthand notation. I'm going to use lowercase p as a probability of getting a 1. Okay,
Sure.
so we don't have all this, I don't want to call it goofy notation, because that causes an uproar with people who use it on a regular basis, right? P over 1 minus p. Okay, p is the probability of something happening. Okay, equals this beta naught plus beta 1 x. Okay, so there's just one variable, one x variable in this case.
Okay.
And this is not to the x. Let's move this thing.
All right, yes. That's part of the diagram above.
There we go. That's
there we go.
All right. All right. Okay, so natural log, maybe, what should I do to undo the natural log?
Do you mean the exponential?
I do, don't I?
There we go.
So I'm going to raise everything here and here to the e. So both of those have been raised to the e.
Mm-hmm.
So that means we just get p over 1 minus p equals e to beta naught plus beta 1 x1. How's that?
Okay.
Okay, it's a long drawn out blah exponent there, but we get the idea. I want to solve for p, right?
Mm-hmm.
So I'm going to multiply both sides. Let me see if I can scroll down a little bit further here. Can I? Yes. Wow. Look at that, man. Now, learning everything here today.
High tech.
So let's multiply both sides by 1 minus p.
Okay.
So p equals e raised to the beta naught plus beta 1 x1. I'm not going to say x1 because it's just 1x.
Mm-hmm.
So let's say just the x. Okay. Bear with me. Times 1 minus that value of p that we're looking for.
Cool.
So it looks like p equals e to the beta naught plus beta 1x minus p times the same bit, right?
Mm-hmm.
Beta naught plus beta 1x. Boom. So now bring this guy, right, over to the other side to get p plus p e to the beta naught plus beta 1 x1. Damn. Every time I think I'm doing better and build a little bit of confidence, then I start writing crappy again.
That's fine.
Equals e to the beta plus beta 1 x again. And now factor out the p.
There we go.
1 plus the e bits.
Mm-hmm.
God, man, this is tiring. Do I have to do all the work here? I'm sorry, I'm just kidding.
You're the one sharing the screen.
I know. God. All right, that bit, that's over the same bit of, that's a plus. Jesus. Come on, man.
That's fine.
Come on. You should actually, for the sake of our for a huge audience out there, you should, become a little bit more strict and, say, consider our viewers, fix that handwriting, would you? Practice or
It's
something.
fine. It's
Oh, is it?
legible. Don't worry about it.
All right. Well, if you had handwriting like this, you'd worry about it. Okay. And now the last step. Oh, here for the final step here. This is cool, man. I didn't realize we had this scrolling feature.
Nice.
Divide by this whole bit. Can I just do this, please? Can I just do this?
Oh, is it not bringing the pen back up?
Hold on. No, that's not all of it. Hold on. This is laziness right here, man. Boom. Oh, I got part of the.
Love it.
Let's put that back where it belongs. Unless we stretch this now. No, I don't want to stretch it. Let me just delete it. That's gone. And then make this an equal sign. How's that? Equal. This
Yep.
is like P equals this. I even put a bigger one there. With a division. Where's the division? Boom. Right? Thank you. Thank you. All right. So as X gets bigger, all right. So here, let's kind of relate that to our graph today. So here were our values of X, and here were the zeros and the ones, right? And so if I imagine if we get a positive value, right? Beta naught is some constant. It's not being multiplied by anything. So it's just a value that we have.
Yeah.
Maybe positive or negative. We don't know. Okay. This beta 1, though, if beta 1 is positive, right? That means as X gets more and more positive, E is getting raised to a bigger and bigger positive value. Correct?
Sounds good.
So that means that if this is getting bigger, right? If the numerator is getting bigger, the denominator is also getting bigger, and it's just 1 plus whatever the numerator is, right?
Yep.
Okay. So if E is really big, then if E raised to that bit is really, really a big value, then 1 over 1 plus that is going to be really, really close to 1, just under 1, isn't it?
Yeah, I would say so.
Right. So if B is small for values of X, right? First of all, the numerator is never going to be negative, right?
Oh, of course, yeah.
Never going to be negative. And the denominator is never going to be negative. It's always going to have a positive value, which is good since we're trying to figure out what P is, a probability. Yeah. Also, every probability has got to be between what two values?
0 and 1.
That's right. So, so if E raised to the blah, blah, blah is really, really small, like really close to 0, then 1 over that really close to 0 is going to be really close to, not 1 over. The number really close to 0 divided by 1 plus the number really close to 0 is going to be really close to not 1.
Not 1?
If it's a number really close
0.
Really, really, yes. Yes.
There we go. Sorry, got that wrong in my head.
That's okay. That's okay. So as we were, that doesn't undo all of my bad handwriting, but it's, no, it's exactly right. Right? It starts from, because it's like 0 over something close to 1, and it moves. Now this is if beta 1 is positive, of course, right? Okay. So we would end up getting something that looks like this. Oops. Oh.
Yay.
Right? Does that make sense?
Yep.
So hopefully, hopefully I should say, if we do get a negative value, and that's not really hopeful because you would want cholesterol to decrease your chances of getting heart disease. If my X value was negative, okay, if my beta 1, then my X value is being multiplied by, and then E is being raised to that. If that were negative, then X times a negative number is going to become more and more negative. We'd get something that would look like this. Bam.
There we go.
Right? Cool.
I like that.
I'll tell you what, just so that we're we're not tiring people out with a lot of this stuff. Maybe we can come back with another video and actually do some code to kind of show how that all works.
Yeah, sounds
Yeah.
good.
Yeah, to keep the video short, right?
Like that.
Yeah,
Yes.
so people can bear us or bear me, right?
Oh, don't say that. Goodness me.
Hold on, what am I doing here? Hold on, let me try to get. Oh, I was trying to share that. Let me close this.
Mhm.
All right. Okay.
That was really cool. I like that.
That was productive, man. I think that was okay. Hopefully.
Yes,
All right. So I'll see you in a bit.
indeed.
Hopefully, and we'll make a few more of these, okay? Because
Sounds good.
everybody's asking about them.
That's so good.
Everybody.
Thank you, everyone. I'm glad you're liking
Thank you.
them.
Thank you, everyone. All right, Laura. It's always a pleasure. I'm gonna I'll see you. I'll see you soon, okay?
Indeed. See you soon. Okay. Bye.